Okay, day 7. Okay, we finished up on series circuits. Okay, and we will go into next topic is the parallel circuits. Now, the problem with series circuits is that they're in series. The components are put in a series type connection, which means a couple of things. The first thing it means is that the current is the same throughout the whole series of connections. Okay, and that's the weakness of it, because if one component opens up, you lose the whole uh, circuit. Circuit goes blank. Okay, that's what used to happen to the old Christmas tree light, Christmas string light, until they start to uh, put them a configure them in a different way. All right, we can't have that in our home. All right, we just can't have that. We can't have one light bulb going off and then destroying our stove and everything else that we have in the house. Okay, any electrical thing that we have in the house. So how do we handle that? So the power has to be used. We have single power coming in, and that power has to be distributed among many different circuits. Okay, and one way of doing that is to have parallel circuits. That is, have a certain source of voltage being available for different a whole number of circuits. Each one of those could be a series circuit, but they're not all connected together to make one huge series circuit. Okay, so today we'll just learn about what is parallelism, and the one thing we learn about that is that each parallel circuit, okay, is handled by the same, can be handled by the one single supply, okay, voltage supply. The other thing we're going to learn is when we make a connection to in between components, okay, whenever you make a connection, either serially or even in parallel, they all come together at a point. Those points where the circuits join each other is called a node, N-O-D-E, a node, okay? And those nodes then represent connections. So then we're going to learn of what Kirchhoff's second law, the Kirchhoff's current law, okay, also very important, that just simply says that any current that goes into a node is got to be equal to the number of currents flowing out of that node. You know, what goes in must come out. You're not going to lose anything just because it's a node. Okay, you conserve. There are conservation rules, both Kirchhoff's voltage law and Kirchhoff's current law are both conservation laws. The Kirchhoff's current law is very simple. You can have two currents going in and one current going out, or you can have any number of them going in and any number of them coming out. Okay, but they all, the sum then of what goes in has to equal the sum of what goes out. So that's Kirchhoff's current law. Okay, but first let's recognize what the parallelism is, what parallel means. We know that, for example, if you have two parallel circuits, okay, two circuits that are in parallel, the voltage applied to each of the circuit is the same. Okay, so you can go figure out what is the current going through circuit 1 by just taking the total resistance of circuit 1 and dividing it into the power source. And you do the same thing for the circuit 2, which is in parallel. It will come out to be possibly a different current. Okay, so that particular supply has to furnish enough current for both circuit 1 and circuit 2. And therefore, the current that comes out of that supply has to equal the sum of the two currents. That's Kirchhoff's current law. Okay, so let's get going on this. We'll go through the lecture, and if you have any questions or having a tough time, let me know. The homework, by the way, is a two-parter. All right, just like this lesson is a two-parter. Today we start the parallel circuits. Tomorrow we end the parallel circuits. So you got Tuesday and Wednesday parallel circuits, chapter 5. All right. So and then on Thursday we will get a combination. Go into combination. Okay, so that's it. I'll talk to you at noontime.